This is the video for Unit 1, and it's Video 1A. We'll be covering a couple of topics in this one. The first one is what we call the segment addition postulate. We abbreviate that a lot of times with the acronym SAP. So it's the segment addition postulate. And what it says is very common sense, but we'll write it down. Basically, it says that if it takes you 5 miles to get from A to B, in which case AB would be 5. And then it takes you 9 miles to get from B to C. So B to C would be 9. Then the entire distance is from A to C, which is kind of like not very earth-shattering. It's pretty obvious that this would be 5 plus 9 equals the whole way across. So what they'll sometimes do is they'll have a missing piece, and they'll say this is X, this is 10, and then they'll bracket this off and say from A to C is 13, and it'll say what's X? And you'd say, well, it's got to be 3 because I'd have to do X plus 10 equals 13. So we're not going to give you the very straightforward ones of that. I'm just going to give you two that have a little more thought involved. I'm not going to help you on ones I don't think you'll need help on. So the question on this first example is to find the length from I, right here, all the way over to K. So first thing I need to do is figure out, well, what other piece do I need in order to determine that? And the answer is, if I could get from I to J, then I could get all the way from I to K by just adding 12. So it's going to be something plus 12. And that something's going to be the length from I to J. So my task is to figure out how far is it from I to J. Well, here's what I know down below. The whole distance is 49, and from here to here is 31. So if I were to take the 49 and subtract off the 31, I'd get 18 for this length. So I know that this is 18, and from J to K is 12. So my answer is from I to K would be 18 plus 12, or 30. So I just let pieces they gave me help me find the ones I did not know. And then on the next one, I've introduced some algebra into the mix, and I'm going to figure out how far it is. There's not a question on here. So let's say I wanted to know what is the length from U to V. In order for me to figure that out, U to V is right here. I would need to get X so that I could plug it in, double it, and remove 18. Well, is there a way for me to get X on here? Well, let's go see what I can set up. I know the whole way across. So let's write that down, is 4x minus 29. I also know that all of these pieces need to add up to that. So I'm going to set up an equation where I say whatever the whole way across is, it certainly has to be 13. And then I travel 6 more. Again, I'm going from here to here, plus from here to here, plus from here to here. And that has to equal the entire distance, which was given to me as 4x minus 29. Now I'm just going to solve this algebraic equation. First thing I'm going to do is combine like terms on each individual side. I've got 13 and 6 gives me 19. Minus 18 is 1. I now have the variable stuck on both sides of the equation, so I am going to move it over by subtracting it from each side. It'll disappear over here. I get 2x minus 29 is equal to 1. I'm now going to attack this x by doing the opposite operation. I'm going to add 29 to both sides. which gives me 2x is equal to 30. I'm going to do the opposite operation of multiplication, which is division. And what I get is x equals 15. But that's not my answer. That gives me the attachment to that arrow. So from u to v is going to be 2 times x, which I just found to be 15, minus 18. So what I get with that is 30 minus 18, which is 12. And I'm done. So that's the segment addition postulate, pretty straightforward. The next thing we're going to talk about in this video, this is a nice short one, is angles and their measures. So you will have to get a protractor from me when you get to this point. And first up, what you do when you're measuring with a protractor, here's my interactive one, is you line the very center T up with the vertex of the angle. So it helps sometimes to put a big dot on here. It helps sometimes to do this in a little bit more bold, and that in a, whoops, I missed it, and this a little bit more bold. And what I'm going to do is line the center of my protractor up at the T right here at the vertex, and then I look at where this is going through 0. Right here you can see the 0, and that's got 10 degrees, 20, 30, 40, 50, 60, 70, 80, 90, and that's going all the way to about 130 or 131. And so my measure of that angle would be 131 degrees. The key is to put your protractor at the V. So here I'm going to wonder if this I haven't used this interactive protractor very often. I'm going to see if it allows me to tilt it. So just give me a second, see if it allows me to turn it. It does. Okay, great. So let's suppose your angle was like this and you had to measure it. Watch how I attack that. I go line the center of my protractor up at the vertex, and then I'm going to tilt this until the ray goes through 0. So I'm tilting, 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 tilting. I'm going to move it over again a little more. It's a little touchy here on my smartboard, but I'm going to do the best I can. There we go. So what I'm doing is I'm making sure that this ray goes through 0, and then I read the protractor. So that would be a 75-degree angle. So again, you've got to tilt it until the very first ray goes through 0 on your protractor, and then you just turn it. Get this back to normal. Move it off to the side, erase all this stuff, and go to the next one. So if you're drawing an angle of a certain measure, what you do is you put your starting ray down. You can use the straight edge of your protractor to do that. Or you're going to run the risk of this happening. I'm getting a very crooked line. So I'm going to go grab my line tool here off my smartboard. And I'm just going to draw a nice line to start me off with. So here's my starting line. And then what most people will do is they like to put a dot at this end and go from there, but you can actually put a dot anywhere you want, but we'll put it right here. And then again, I'm going to line my center of my protractor up with that vertex. I'm going to turn it so that I'm going through 0, and then I'm going to go to 42 degrees. So I've got 10, 20, 30, 42. And then I'm going to draw another line emanating and going right through 42. And when I'm done with that there, I've got myself a nicely created 42-degree angle. So that's it for this video. It looks like it's a stop, and you can stop and go do worksheets number 1.1 and 1.2. You might want to have me initial these chunks as you work through them, so I'm not stuck doing a whole bunch before your test. But again, remember you are required to have both the notes and the worksheets in order to have access to the test, and you can't pass the class without passing the test. Have a good one, guys. Peace out.